Good morning. Thank you for joining us. Today we'll be speaking with Bernard Frings from Brainstorm Electronics. Brainstorm Electronics is a company based in Southern California. Bernard is the president, also heads up our European operations out of his facility in Brussels, Belgium. My name is Jim Pace. I'm with Plus24. We're the worldwide distributor for the Brainstorm product line. Good morning, Bernard.
It's great to be here. Good morning, everyone, and thank you for joining us. Today's discussion will focus on our DXD universal clock and PTP sync. Brainstorm Electronics has been around for a long time. We have worked with Plus24 for many years. Our products are designed in close collaboration with them. At the top of the slide, some of you may recognize our TV4 communicator. That was our first product. The SR15 was very popular in transfer houses and post-production studio. His success was due to some unique features, but maybe also to its funny name, the timecode distripolizer. Another distripolizer came right after that, the DXD-8, which was also a great success in post-production studios. Those have now been replaced by the DXD-24 and the SR112, currently in production. And that brings us to the DXD universal clock, the topic of today's discussion. We are announcing the availability of the PTP firmware and the GPS receiver for both models. Why a PTP box? Well, as a dedicated box, it will be secure and fixed, and being a Brainstorm box, we designed it to be versatile and reliable. We made a short video on the DXD. I'd like to show it to you. It's just a few minutes long.
Established in Los Angeles in 1987, Brainstorm Electronics now introduces the newest in world-leading pro audio video sync solutions. In this new era of media over IP, the latest development from Brainstorm Electronics is the DXD Universal Clock Line, designed to be the central source of time in a modern audio-video installation. It combines PTP clocking for Dante, Ravenna, AES67, SMPTE2110, GPS, plus audio and video legacy sync formats. Audio, video equipment, and the IP network are in perfect sync, making the DXD truly universal and versatile. It has the capability of being a PTP slave or a PTP grandmaster and gives the operator exceptional flexibility. First, as a standalone master locked to its internal oscillator or GPS, it will provide sync to the network via PTP ports and to the legacy equipment via the unique Brainstorm assignable BNC outputs simultaneously. Second, as a PTP master, the DXD can lock to an external sync source, such as a 10 MHz sine wave, word clock, AES, or any standard video sync, so the IP network can lock to an existing sync source. Third, as a PTP slave, it can generate legacy sync to keep the legacy equipment locked to the network. Two different models exist, the DXD-16 and the DXD-8. For legacy clocking needs, the Precision Multi-Format Reference Generator provides up to 6 different clocks simultaneously on the DXD-16 and up to 4 on the DXD-8, all referenced to the master source. On the PTP side, the DXD-16 uniquely has 4 independent Ethernet ports. The DXD-8 has 1. Both can handle several hundred slaves. 16 user assignable outputs are available on the DXD-16, and 8 on the DXD-8. These outputs can be configured in groups for any standard clock signals, audio or video. There are no dedicated output limitations. Both units have a battery backup for the internal real-time clock that can generate time information when the selected reference does not. Word clock, AES, or video sync now offer this new feature to the network. A GPS receiver can be installed in either unit. GPS not only provides an extremely accurate timing source, it also enables DXDs in remote locations to be locked and in phase with one another, Additionally, with the GPS option, the DXD will have a higher priority as a PTP Grandmaster. Flexible, reliable, and easy to use, the unique DXD line keeps traditional equipment relying on Blackburst or word clock perfectly synchronized with a network and its equipment using the AES67, SIM22110, Dante, or Ravenna formats for media over IP. Learn more at brainstormtime.com.
As mentioned in the video, there are two different models, the DXD-16 and the DXD-8. The main differences between the two are the number of BNC outputs, the number of PTP ports, and the number of different signals that can be generated simultaneously. One of the main functions of the DXD is to generate high-precision reference signals. The DXD-16 has 16 BNC outputs. These outputs can be used for any of the generated signals, audio or video. There are no dedicated outputs, which gives the operator great flexibility. The outputs are assigned in 6 separate groups. Each group can generate Blackburst, tri-level sync, word clock, AES, or 10 MHz. The DXD-8 has 8 BNC outputs. They are assigned in 4 separate groups. It's important to note that multiple rates can be generated simultaneously. For example, 44.1 and 96, or 25 and 29.97. For even more flexibility, the DXD can lock to a wide variety of references. Internal has an option, either the standard temperature control oscillator or an optional OCXO card can be installed in the unit. As external references, there is PTP, GPS, BNC input A, BNC input B. Those 2 BNC inputs are like the outputs, they are universal, so they can accept word clock, AES, video sync, or 10 MHz. In addition, input B can be set as an alternate reference to replace reference A in case of failure. As a PTP device, time of day is central to the DXD design. Several sources of time are available. GPS, that's the best source of time, NTP, PTP, timecode. There is also an internal real-time clock which will generate time of day when the reference is a rate only, and that would be the case when you're using internal crystal, word clock, AES, video sync, or 10 MHz. Let's take a look at different scenarios to illustrate how flexible the DXD can be. Here we have a traditional facility where Blackburst would often be the main sync. This could also be HD tri-level sync. The DXD will generate all the traditional sync signals, so audio video equipment can lock to it. It will also generate PTP sync, so that an IP island with maybe a Dante or a Ravenna system can also lock to the facility's main sync. Configuring the DXD to lock to Blackburst is done through front panel menus. Here in the reference menu we have set input A. Input A is also set to accept video, and the ports are enabled so that we can generate PTP sync. Priority 1 is also mentioned. That's a PTP parameter, and it needs to be low enough so that the DXD will become the PTP Grandmaster. Here we have an opposite scenario. In an IP facility, the Grandmaster would be the main source of time. So the DXD would lock to the Grandmaster and generate PTP sync for all the AV over IP equipment. It would also generate at the same time all the traditional sync signals like word clock, AES, video sync, timecode, so that a legacy island could could also lock to the PTP Grandmaster. Configuration here uses the same menus. Reference is set to PTP. The ports are enabled so that we generate the PTP sync. And priority 1 here would not want to be too low because we want to slave to an existing Grandmaster, not become the Grandmaster. Some of you may not be very familiar with PTP yet, so let's take a closer look. PTP stands for Precision Time Protocol. It's a published standard, IEEE 1588. It is designed to synchronize all the clocks on a network. It does it very accurately in a sub-microsecond range. In a PTP network, the first thing to do is to select a Grandmaster. That is done through the BMCA, the Best Master Clock algorithm, where all the devices will compare the clock qualities of each device and select the best one. When a Grandmaster has been selected, messages and timestamps are exchanged between the master and the slave to determine the delay and the offset. With that information, the slave will adjust their clocks so that they match the master. PTP has been around for many years and is used in a lot of different industries. In our media over IP world, pretty much every system uses PTP for sync. It's part of several standards, AES67, SMPTE 2059, 2110, and of course systems like Dante and Ravenna use PTP for sync as well. The DXD-16 has 4 independent PTP ports. Those can each be configured individually as either part of a master-slave group called the boundary clock or as independent masters. Each of them can communicate with many slaves, and on the front panel will be displayed the state of each port very clearly. So let's take a look at a boundary clock. It's defined in IEEE 1588 as a device having multiple ports, one of them acting as a slave, the others as masters. Now, from the audio-video world that we come from, having one slave and multiple masters seems different than what we've been used to. Actually, what happens is that the slave port receives the time from the Grandmaster and distributes it through the other ports to the slaves downstream. Why do we call it a boundary? Because it acts as a boundary between the slave devices and the Grandmaster. As you can see here in Studio A, B, and C, the slave devices communicate with the DXD-16 and not with the Grandmaster. Configuring the DXD-16 for a boundary clock, we would set the reference to PTP, and every port participating in the boundary clock would be set to master-slave group. And priority 1, we would want to keep it not too low so that the DXD-16 does not become the Grandmaster itself. Another way to use the 4 ports is to have 4 Grandmaster ports. And the way that's done is whenever you select any reference other than PTP, the ports will become master only. So in this case, the DXD-16 has the GPS as a reference, and every port is set to master-slave group. If priority 1 is set low enough, the DXD-16 will become the Grandmaster, and the 4 ports will assume the state of Grandmaster. A variation on this is to use 4 independent masters. The difference between the previous setting and this one is that in this case, the 4 ports are operating on a separate PTP domain. You can see the little numbers next to the on the display next to the independent master label. It's 101, 102, 103, 104. Those are the domain numbers for each of the 4 ports. One important note from a security point of view is that although the DXD-16 have 4 ports, it is not a switch. No data can ever be transmitted from one port to another. And the reason why it was designed like that, and the reason why it's important, is that you don't want to have to worry about sensitive data being transferred from one network to another through the DXD-16. Here we have a second DXD-16 set as a passive grandmaster. The reason for this is that the second DXD-16 will act as a backup if something happens to the first one. Both of them are connected to the switch, and priority 1 is set to 10 on both of them, so that it is guaranteed that one of the 2 will be the grandmaster. Because they have the same clock quality and they're both locked to GPS, priority 2 is the one that will determine which one becomes the grandmaster. So we set the second DXD-16 a little higher than the first one. So in this case, DXD-16 number 2 is in a passive mode. If something was to happen to DXD number 1, DXD number 2 would transition from passive to grandmaster. The same can be done in a redundant system. So here we connect a second port from each DXD-16 to the second switch. The priorities are set the same way, and so we have the redundancy at the switch level, but also at the grandmaster level. Today we're announcing the availability of GPS receivers for both DXD-16 and DXD-8. The reason why GPS is important is that it provides an extremely accurate time reference. GPS also provides time of day. The GPS receiver is also very useful because DXDs in remote location, when locked to GPS, will be locked and in phase with one another. Now let's take a look here at an example with 4 independent studios. Each has a DXD-8 as their main reference. The DXD-8, of course, is generating all the traditional sync as well as the PTP sync. The 4 studios are totally independent. You can have 44.1 in one studio, 48 or 96 in another. They're set individually, but being PTP slaves locked to a DXD-16 PTP grandmaster, the 4 studios would have a common reference. A similar result can be accomplished by installing GPS receivers in each of the DXD-8. Now they are each their own grandmaster, but they still have the common reference through GPS. One last thing I'd like to mention is that the DXD can be remotely controlled through the embedded web server. This is how you would update firmware, monitor the unit, or change its settings. Each of those web pages have a header which includes device information, reference information, lock status, system time, and GPS status. The unit is monitored through the status page, and there are several configuration pages to configure the different parameters. Of course, this is restricted to users with specific permissions for security reasons. And that concludes our presentation. Thank you very much for attending.
Thank you, Bernard. If you would like more information, please be sure to contact us at plus24.net. And of course, there's copious amounts of information for you at brainstormtime.com, as you can see on the screen, brainstormtime.com. We look forward to your questions and your interest in the product, and thank you for attending.